Hello YouTube, welcome to my channel, and my name is Paul, and today I want to show you how to do the gesture robot using the Arduino. That's using the microcontroller, and then using a glove just make a gesture control robot. Okay, karibu sana. Okay, first of all, you need a robot chassis. That's the one that you're putting all your stuff on, you're mounting your stuff, and then you need an accelerometer. The one that's an, what's an accelerometer? You can Google that. It's something that helps sense the orientation of an object in space. And then you have the Atmega 328, or you use the Arduino. You have the decoder and encoder. You need an L293 motor driver. You need a 433 megahertz radio transmitter and receiver, and then you need a glove. You need a battery, 9 volt. This for the transmitter, and here this for the receiver on the board itself. Okay, if you have all this, then you're good to go. Okay, right here I have a glove that I mounted the transmitter module. You see here we have the XDL accelerometer, and this is the Atmega 328. It's programmed using the Arduino. You can also check on taking the Arduino off, but it's pretty cheap, guys. So you don't have to use like the whole of Arduino. You see this, like this space. You see I'm using everything, just this single space. And then here I have the HT. I'm using that's the HT 12E. That's for the encoder. And then I got a power supply here. These are the antenna that's made. This is the radio transmitter, and that's all. Nothing much. Then I stuck this using hot glue, so it's just something very compact. And the power supply to put on your 9 volt battery, then an LED to indicate if it's on. That's so simple, guys. Okay, now this is the robot itself. This is the chassis. You see, it comes with battery pack, wheels, the motors, and yeah, these two motors and the caster wheel. So all you have to do is just put on your microcontroller, your sensors, your stuff. In this case, there's not like a real sensor apart from the radio. There's the radio receiver, and right here I'm using the HT12D. That's a decoder, and then this is the motor driver for driving these two wheels. These are just a two-wheel caster wheel based robot. So here with a little bit of passive component, this LED shows if there's any signal being received. All these are other just passive components for help these integrated circuits work. And there's a switch here for turning it on. And when you turn it on, since these LEDs just configured to get the decoder information from here, you won't see anything. But if I turn on the encoder, the transmitter side, you'll see the commands being sent, and then they're being received by this side. And then you see the LED will make some blinking according to different types of information being received. So I'm using these alkaline batteries directly. These are around 6 volts, 6 point something. And then the good thing, there's no regulator in this side if you're using directly, because there's no microcontroller here. I'm just using directly to drive these volts, like 6 volts directly to the motor. That's good because I'm saving a lot of power. I'm not using like the ALM 75 LM 7805 to regulate the power that I'm using to drive this motor. So I'm saving some power on that. That's the good thing with this thing. If you're using only these two chips, you don't need to step down your voltage, like regulate it or something like that. And then there's this antenna to help the signal, because this radius sometimes there's a problem, but you can use that to regulate your not to regulate, sorry, to boost your signal so that it's clearer and there are no missed commands. Okay guys, we'll see. Let me power it on, wear the glove, and then you see what happens. Okay guys, that's the code, and you see basically you start by creating these pins, the analog pins. Some of the analog, two analog pins, like one is high, the other one you pull it low, the other one you pull it high, to create a virtual VCC and ground for the accelerometer. And then there are other three pins, you use them for the X and Y Z axis for the accelerometer. And then there are variables here for storing the data from the analog pins that you're reading from XYZ. Now in the setup function, you declare those pins as output, input appropriately, self-explanatory. And then you see here you're pulling one low, the ground low, and then the VCC you're pulling it high to just create a power source. And then in the loop function, you're reading the pins as they receive data, and then assigning those pins. You assign the variables to those pins as how you're storing the data. Then you use it. The else if else statements here, you use them to make decisions. There's a conditional statements, and then you call in the functions. Now the functions are just below this thing. As you know, the Arduino has automatic prototype of functions. Is the stop functions, forward function, back function, uh, then backward. You have left, right, yeah, around 85 lines of code. So you can just check this code, and then the variables might be, I mean, these values here might be different. These values might be different for you, but you just have to try and check, because these are analog values. They might differ, but you just still have to do some try and error and you find it. Okay guys, yeah, there we go. That's it.